Namaste and welcome back to the DSA classes. My dear friends, today we are going to be discussing a very famous question called as search in Bitonic array. And this question was asked in PhonePe, guys. So a highly reputed product-based company and definitely one of the jewels in the Indian startup ecosystem which has made it really, really big, right? Now what does this question say? The question says, given a Bitonic sequence A of n distinct elements, write a program to find a given element B in the Bitonic sequence in big O of log n times. So the time complexity of search should be big O of log n. Now this is a must. So the question is, what is a Bitonic sequence? Note, a Bitonic sequence is a sequence of numbers which is first strictly increasing, then after a point strictly decreasing. Now what does this mean? Let me show you some examples. Let us assume the first input, I have a list given to me A or an array in which I have these elements. So see 3, 9, 10, 20. As you can see, it's strictly increasing. After 20, it's strictly decreasing, 17, 5, 1. Now they'll give you a value B which is 20. Now you must search for 20 in this array A. So this A is a Bitonic sequence. Till a point it strictly increases, then it strictly decreases. Now is 20 there? Yes. At which index is 20 there? 0, 1, 2. Right? 3, which means the output should be 3. One more input. Assume this is the Bitonic sequence. 5, 6, 7, 8, 9, 10. Then it reduces 3, 2, 1. I am searching for 30. Is 30 there in the Bitonic sequence? No. No means minus 1. I hope you understood what is meant by a Bitonic sequence, right? Now, before we arrive at an algorithm to solve this, I would like you guys to first revisit binary search, because ultimately you're searching in an array, and whenever search has to be done with a time complexity of log n, you know log n is nothing but the time complexity of binary search. Which means one way or the other binary search only has to be implemented here. How to implement it, we will see, because this is not like strictly sorted. It's not sorted like it's all ascending or all descending, but we will see how to do it. Any which ways, first let us assume I have an array like this, guys. I have an array like this. Now one thing what I want you to see is this array is sorted, but not in the ascending order. It is sorted in the descending order. What if I ask you to perform binary search on a descending array, on an array which is sorted in the descending order? Let us assume the key value that I want to search for is 36. Yes, 36 is present at the index 4, but how will you implement it? Now very simple. Binary search means you need low, you need high, and you need mid. So I'm just bringing up the table. Initially low is at the 0th element, high is at the last index, right? So L is 0, H is 6, and mid is low plus high divided by 2. So it becomes 3. So mid is at 3. Now tell me, is the element present at the index 3 equal to the key? No, it is not equal to the key. If it is not equal to the key, you now check if in case the key is greater than or lesser than the mid value. Now look at this and tell me, is 36 greater than or lesser than 41? It is lesser than 41. If it is lesser than 41, if this was an ascending array, it was sorted in the ascending order, then 36 will be to the left side, not the right side. But because it is in the descending order, 36 will not be on the left, 36 will be on the right side, which means you will not adjust H, you will not adjust the high pointer and bring it to one step behind mid. You will not do mid, H is equal to mid minus 1. Instead, this low pointer you must make it mid plus 1. I hope all of you agree, which means low value is going to become mid plus 1. High value is going to be the same, which means low value is going to come here. And then when you again calculate mid, 6 plus 4 is 10, 10 divided by 2 is 5, mid is going to be at 5. Mid is going to be at 5. I hope you're able to think. So very simple. Ascending array, if it was lesser, the condition should now become for greater. Greater condition should become for lesser. Would you agree with me? Anyways, so this is the new values. Mid is 29, key is 36, not equal. Now tell me, is it greater than or lesser than? Oh, it is greater than. If it is greater than, it will not be in the right side. It will be in the left side, opposite of ascending array. Hope you're able to think. So what should you do? Should you adjust low or should you adjust high? You should adjust high. High should become mid minus 1, right? If high should become mid minus 1, this is where high is going to come. This is where high is going to come, which means high is going to become mid minus 1. Low will be the same. Now both are 4. Add them together, divided by 2, 8 divided by 2 is 4, which means mid also is going to be in the same position. Any confusion till this point of time? Yes sir, we understood. Now tell me, is the element at the mid position equal to the key? Yes, you have found it. Return the index. So I am bringing the binary search algorithm. If you notice here, if in case key is equal to mid, then return mid. Else, if in case key is less than the mid element, you are adjusting high. This will work for ascending, not for descending. If it is descending, my friends, this particular condition, whatever you are doing, should actually be this. I am swapping them. I am swapping them. How are you able to think? So this is the only change you have to do if in case you are performing binary search on a descending array. How are you able to think? Everything else remains the same. Now why was this important for me? I will tell you. Now let's go back to our original question. So our original question is, you are given a Bitonic sequence A. A Bitonic sequence is such a sequence where it's strictly increasing till a point and then strictly decreasing from that point. How are you able to think? And in a Bitonic sequence, you must search for a given value B. Let us assume B is 20. How are you able to think? Now, let us come up with an algorithm of how we would be solving it. Now, it's very simple, guys. Would you agree that ultimately, if in case you want to solve this search operation in big O of log n time, if this time complexity is important for you, then ultimately log n time will only be possible if n, or the size of the input, keeps reducing by half every time. Only if it is reducing by half every time, only in log n time you will be able to do it. So would you agree we will have to keep splitting this array? Now tell me, which would be a point where it will be ideal to split? I would say that find that point where the sequence stops strictly increasing and then starts to strictly reduce or decrease. And that point is nothing but this. How are you able to think? Or in other words, what is special about this value? It is the maximum value present within the array. Because see, it keeps strictly increasing. This is the maximum value. Whichever is the maximum value, from there it strictly reduces. So I want to find this point, this index I want to find, where the sequence stops increasing and then starts decreasing, right? Now this value, which is the maximum value in a Bitonic sequence, is called as the Bitonic element, and the index of the Bitonic element is called as the Bitonic index. So first of all, I want to find that Bitonic index or that Bitonic point I want to find. After finding, what will you do, sir? We will see that, but this is my algorithm. Step 1, find the point where the array can be split, which is the Bitonic point. Once I identify the Bitonic point, I will now check if the element at the Bitonic point is equal to the element that I am searching for. I will check that. If it is equal to the element that I am searching for, then I will just return that index. I will just return that Bitonic point. But if it is not, otherwise, what will I do? Otherwise means, I know this element is not the element. Now the element can be to the left side, the element can be to the right side. We don't know which side it will be. So I must perform search operation here, I must perform search operation here. But because the time complexity has to be log n, I must be applying binary search only to the left. I must be applying binary search only to the right. And if you notice, all the elements to the left of the Bitonic point are all ascending. So normal binary search I can apply. But all the elements to the right side are all descending, which means just now I showed you how to apply binary search on descending elements. So this part is easy. How to apply binary search here, how to apply binary search here. But the question is, how does one find this Bitonic point is the bigger question. So I hope the algorithm is clear to everybody. What is the algorithm? Find the Bitonic point. Check if the element is at the Bitonic point. If not, apply binary search to the left of the Bitonic point, apply binary search to the right of the Bitonic point, and see if the element is present. I hope you're able to think, right? So some kind of an algorithm we have come up with. So first step is how to approach or how to find this Bitonic point. Let me try to explain. Guys, very simple. I want you to observe. Let us assume this is a new array in front of me. And this array is a Bitonic sequence because see 5, 6, 7, 8, 9, 10 strictly increasing, then 3, 2, 1 strictly decreasing. I want to find this 10, that is my Bitonic point. Now how will you do that? Very simple. What I will do is, even searching for this Bitonic point, must happen in log n complexity. If it must happen in log n complexity, then somehow I have to keep reducing the size of my input when I am searching for that Bitonic point. So how will we do that? Very simple. Let's try to apply some binary search kind of algorithm here. So what I will do is, I will set one pointer called as L for left, and I will initialize it to the starting. I will create a pointer called as right or R. I will initialize it to the ending. I also want to find the midpoint. Now why will you do that, sir? Let me explain. I'll create a table. In the table I have left, right and mid. Left is 0, right is 8. Now mid is 0 plus 8 divided by 2, which is 8 divided by 2 is 4. I hope you're able to think. So mid now becomes 4. Now very simple. I want to check whether the element present at the mid is my Bitonic element or not. Is my Bitonic point or not. Now how will you check that? Some conditions you have to write, but what can be a condition which will help you identify a Bitonic element? My friends, it's simple. Look at this. Which is the Bitonic element? 10. What is unique about 10 is the element to the left is lesser than it, or in other words I can say 10 is greater than the element to its left, 10 is greater than the element to its right. And let me tell you, the Bitonic element is the only element in this entire sequence which will be greater than both the element to its left and right. No other element will do that. Why, you may ask? Simple. Let's take 9. 9 is greater than the element to its left. Is 9 greater than the element to its right? No. Let's take 7. Greater than 6, but it's not greater than 8. Let us take 3. 3 is lesser than the element to its left. It is lesser or greater than the element to its right. Let us take 2. 2 is lesser than left, greater than right. So tell me, which is the only element which is greater than the element to its left as well as right? Is nothing but the Bitonic element. 10 is greater than 9, 10 is greater than 3. Which means, would you agree that to check whether the element at the mid position is Bitonic, this is the condition I should write, which is if in case the element at the mid position is greater than the element to its left, so mid minus 1. And that is not the only condition, it should be greater than the element to its right also. So the mid element should be greater than the element to its right, mid plus 1. This is mid, mid minus 1, mid plus 1. If this condition is true, I have got my Bitonic element and hence I will just return the position. That is only my Bitonic index or Bitonic point. But if that is not the case, see this condition, is it true here? 9 is greater than 8, but and is 9 greater than 10? No, false. False means else. Now I want to know whether my Bitonic element will be to the left side of mid or whether my Bitonic element will be to the right side of mid. Now, how do you analyze that? Well, it's very simple. Tell me, look at 9. 9 is greater than 8. 9 is lesser than 10. If you are at an element which is greater than the element to the left but is lesser than the element to its right, are you in the increasing side of the sequence or are you in the decreasing side of the sequence? Anyone who has common sense will tell me, sir, if you are at an element who's greater than the left but is lesser than the right, you are still in the increasing side. Well, if I am in the increasing side, tell me, the Bitonic element, will it come to my right side or will the Bitonic element come to my left side? Naturally, Bitonic element will come to my right side. I hope you are able to think. Which means I must now adjust the range of my search. How will I adjust the range of my search? Very, very simple. All I will do is I will take this L. Bring it wherever M was. I hope you are able to think. I will take my L, place it wherever M was. Then I know, because it will only be towards this side. Any confusion till this point of time? So, watch it. That is what I am showing as the table. L will become equal to M. R will be the same. So, see, else if in case the element at the mid position is greater than the element to the left and is lesser than the element to the right, then please make sure that L comes wherever mid is and R remains the same. Okay. However, watch it carefully. Now again I will find mid. 8 plus 4 is nothing but 12. 12 divided by 2 is 6, which means mid becomes 6. Any confusion? Now again check. Is this the Bitonic element? If this was the Bitonic element, it will be greater than left, greater than right, which is this condition. 100% it is not greater than left, it is greater than right, which means this condition is not satisfied. If this condition is not satisfied, I will come to my else condition and again I will check. If in case I am in the increasing part of the sequence or decreasing part of the sequence. To check if I am in the increasing part of the sequence, I am checking if in case the element is greater than the left side but is lesser than the right side. If you look at this element, it is lesser than the left side but is greater than the right side, which means this condition is false. If this condition is false, it means that I am in the decreasing side of my sequence. Naturally, you are in the decreasing side of the sequence. If you are in the decreasing side of the sequence, the Bitonic element, will it come to the left side or will it come to the right side of mid? If you have eyes, you can see the Bitonic element will come to the left side. If Bitonic element has to come to the left side, then tell me, what should you do? Should you adjust L or should you adjust R? You have to adjust R. And where will R come? R will come wherever M is. Hope you are able to think. R will come wherever M is. Which means R becomes same as M. L was the same. And that is what I am telling. Else, please make sure R becomes equal to M. Any confusion till here? Again find mid. 6 plus 4 is 10. 10 divided by 2 is 5, which means mid now becomes 5. Now check. Is this a Bitonic element? Yes, because greater than left, greater than right. So this condition will be true. If this condition is true, you have found your Bitonic point. Point means what? Index. What is the index? M. So I will return M. I have found my Bitonic point. Now that I found my Bitonic point, I can go and write the rest of my logic, because all I have to do is check if this Bitonic point is the element I am searching for. If it is not, then I will apply binary search to the left, I will apply binary search to the right. Now, this logic of finding the Bitonic point, till when will this sequence keep repeating? Let us assume, guys, that this value, till when will it keep repeating, if you ask me? Let us assume Again, once more, if you notice here, the condition is very simple. First and foremost, it is guaranteed to you that in the input there will be a Bitonic point because they are giving you a Bitonic sequence. So somewhere this condition will be true, you will return. But if you have to write a condition, it's very simple, same as binary search, right? If left value becomes greater than right value, then you know you have not found your Bitonic point at all. So if in case I have to write a condition here, what I would do is I will tell, please repeat this as long as left is less than or equal to right. This would be my condition. I hope you're able to think. So as long as this condition is true, this will keep working. So it's as simple as that. So I hope the exit condition all of you have been able to understand, and how to find the Bitonic point you have understood, right? So the concept is simple. The Bitonic element is such element which will be greater than both left and right. And how to check whether you are in the increasing side of the sequence or decreasing side of the sequence also, these two conditions you have been able to understand. Okay, so you now know how to find Bitonic point, you know how to do binary search on ascending elements, you know how to perform binary search on descending elements. Now we have to take these three things, combine it as one, and write our program and get a job in PhonePe. Okay, so what are we waiting for? Let's get started. Now it's time for us to write code. Now watch it, guys. First of all, I want to write two functions, one to perform binary search on ascending side of the Bitonic array, and one to perform binary search on the descending side of the Bitonic array. Okay, so what I will do is I'll create a function. I'll call it as ascending binary search. And ascending binary search is nothing but a normal binary search only. Okay, so this will take my array A, and then I'll come inside this and of course key also. Next I'll come inside this, and what I will do is, this is the binary search logic, nothing new, same thing. Okay, so as you can see here, if key is less than the element at mid, you're adjusting high. If it is greater, you're adjusting low. That will work when it is ascending. Now what I'll do is I'll copy this entire function, paste it again. And there I'll make it as descending binary search. Scroll it. I'll make it as descending binary search. Next, only difference here is, if the element is lesser than the mid element, because it is descending, high should not be adjusted, low should be adjusted. So see, this should come on top. That should go down. Just interchange the positions. That's it. And if you come out of the loop, it means you have not found, so -1, right? I have these two ready. Now I will come. Yes, you can reduce the size, minimize it and keep it. So I have both of them ready. Now watch it, guys. What I'm going to do is, now I'll create the function to find the Bitonic point. That is important. So I'll tell static int, because I need the index of the Bitonic element, find Bitonic point. Awesome. Next what I will do is, I will come here, this will also take the same array, right? That's all it needs, it just needs my array. Next I will come inside that. Now I've already told you the logic to find the Bitonic point. So as long as, I'll just first create left, right and mid. So int L is equal to 0. R is the last index, so a dot length -1. Then mid is initially 0. We'll give it a 0. Next I'll put the while loop as long as left is less than equal to right. Then I'll come inside this and what I have to do now is simple. What is the condition to find the Bitonic point? If in case the element at the mid is greater than the left element, mid -1, and is also greater than the right element, mid +1. If this is the case, I know that at mid is that Bitonic point, so return mid. Okay, otherwise Otherwise, now you might be asking, sir, mid is 0, sir. Shouldn't you tell left plus right divided by 2? You're absolutely right. So first let's find the mid position. So I'll tell mid is equal to L plus R divided by 2. So first you have to calculate mid, otherwise it will always be 0. Okay, great. Else, if in case. Now why if in case? I'm checking whether, whether I am in the increasing side of the sequence or decreasing side of the sequence. If I am in the increasing side of the sequence, the element will be greater than the right side, but will be lesser than the, will be greater than the left side, but will be lesser than the right side. Would you agree with me? That's what I'm doing. So A of mid is greater than mid minus 1 and is lesser than mid plus 1. Simple, guys. Everyone understood? If that is the case, then what should I do? What I should do is I should adjust the search. So what I will do is, what will you adjust? Tell me, will you adjust left or will you adjust right? Obviously, you have to adjust left. So obviously, you have to adjust right? So I will tell R is equal to M. M is equal, mid. So mid. Any confusion? Next, else. So if it is not the bitonic element, if it is not the left side, then it means the right side. It's a decreasing sequence, right? So then what should you adjust? L. So L is equal to M, I'll tell. L means mid. Any confusion till this point of time? Good. I hope everybody understood. Now, if I come out of this loop, what does it mean? That I have not found the bitonic element. But it will never happen because the input will have bitonic element. But unfortunately, this function will give you an error. Because it is telling, hey, what if in this while loop, this condition never gets satisfied? What if this never gets satisfied? We know it will get satisfied, but it's the expectation of the language. So we will just put a dummy return statement until -1, and you know it will never be -1 because you will always have a bitonic element. Any confusion? I'll minimize this also and keep. Now I have ascending search, descending search, I have my bitonic point also. Now see what I will do. I'll come to my main function. In the main function, scroll a little bit on top. What I'm going to do now is, first and foremost, I want to find my bitonic point. But you have A, now you need B also, which is the element you're searching for. Let us assume B is equal to some 8. B is 8. Now I'll come down. First of all, I want my bitonic point. So I'll call this function, find bitonic point. I'll pass A. It will return something to me. It's the bitonic index that I will collect it in a variable called as B index. B index means bitonic index. Any confusion till this point of time? Now what will you do with this bitonic index, sir? Now watch it. Now I will go create one more function, which is the actual logic of the program, which is to perform search on my bitonic array. So I'll tell static int, okay, search bitonic. Search bitonic, and inside that I'm going to pass my array A, and also I'm going to pass the element I want to search for, which is the key, and I will also pass my bitonic index. Any confusion? Now using these three, see what I will do. Very simple. This is the array. As of now, the bitonic index will be index of 10. So that is 0, 1, 2, 3, 4, 5. 5 is the bitonic index. What you are searching for is 8. What you are searching for is 8. Now see what I will do. First and foremost, I will tell if in case, I will check if the element I am searching for, which is the key, is equal to the bitonic element itself. How will I check that? Bitonic elements index you have. So check A of B index. Okay. But if this condition is true, directly return the bitonic index, because that is where the thing is present. Any confusion? But you know, Bitonic index is 5. Scroll it. Delete these extra lines. This, you know that the Bitonic index is 5. You know that at 5th index you don't have 8 because what you're searching for is 8. So this condition will not satisfy. Now I'll come outside. Now guys, I want you to think a little bit optimally. We found the Bitonic element. Now we checked if the element at the Bitonic point is the element that we are searching for. You know that it is not the element. If it was, you return the Bitonic point. But if it is not, then you have to do binary search on left and right. But before that, think about it. Guys, let us assume the element I was searching for is 80. Make that 80. Good. Now, when you come here, you will first check if in case the key, which is 80, is equal to this element at the Bitonic index. No. No means tell me Bitonic index is the largest element in your array. That is how Bitonic sequence is. It is the largest element in array. Your element is greater than the largest element. If it is greater than the largest element, will it be there anywhere? It will not be there. So should you waste time searching to the left, searching to the right? Meaningless. Nobody would want to waste time. So would you agree? By just adding one more condition here, you would have saved so much time, which is if in case the key value is greater than the element present at the Bitonic index, then I am just going to return -1, which means it's not there. Simple. Oh, great, sir. What else, you may ask? Now, we know it is not at the Bitonic index. We know that it is not greater. Now you have to search to the left, search to the right. It can be in both sides. How will you do that? Simple. You have to perform binary search. Now look at this. This is your B index. You checked if that element is the B index element. No. You checked if it is greater. That also you checked. Now what I am trying to say is you have to search to the left. You have to search to the right. You have to do ascending binary search. You have to do descending binary search. Now, if you go on top, look at this ascending binary search function. If I call this, I'm passing my entire array A and I'm passing the key. Okay. But I'm not telling that, hey, ascending binary search, you have to only perform search from 0th index till this 4th index. I'm not telling that. Similarly, descending binary search, I'm not telling, hey, descending binary search, you must do search from 6th index till 8th index. I'm not telling that. I'm passing the entire array. And if I pass the entire array, this guy will search from here till here and it will not even work properly because it is not completely sorted. This array is not completely sorted. Till here it is sorted, from here to here it is sorted, but completely it's not sorted. So these will not work because you know, basis of binary search is sorted, either ascending or descending. I hope you're able to think. So now it's very important that we, before calling this, also tell them from where to where they have to work. So that is very simple. All I have to do is, if I expand ascending binary search, you can notice L is there and H is there. L is 0. H should not be length -1, it should not go to 8. It should be here. Here means what? B index -1. Would you agree with me? It should be B index -1. So what I will do is, I will remove this A dot length -1. And here I will maybe just initialize it with a variable called as range. You can just tell range like this. Now what I will do is, I will pass that range here. Which is that range? I'll pass that range. And that range will be B index -1. Hope you're able to think. Similarly, I'll now decrease this. I'll go to descending binary search. In descending binary search, you know L should not begin from 0. L should begin from 6. 6 means B index +1. And the H should be the last one only, length -1. So this is okay. Now L should not be 0. So I'll remove that. I'll just tell range. And I'll pass that range. What is the range I will pass? B index +1. For ascending search, I am not setting L, I am setting H. And H is going to be B index -1. I hope you're able to think. So now see, I'll come down, and what I'm going to do is scroll a little bit on top. Here I'll come, very simple. First of all, I will call ascending binary search. Now A key range is B index minus 1. Simple as that. Okay. Now whatever it returns, I'll collect it in a variable called as result 1. Result 1. Now I'll come inside and I'll check if in case result 1 is not equal to minus 1. Not equal to minus 1. Not equal to minus 1 means when does it give minus 1? When it's not found. If it is not equal to minus 1, I'll return result 1 because that only is my index. Good, great. However, I'll come outside. Now let us assume it did not find in this side. Now I should search this side. This side is descending binary search. So I'll call descending binary search. And here the range that I will be passing to it is B index plus 1. Plus 1. Whatever it returns, I will collect it in result 2. Then I will check if in case it did not find means result 2 will be minus 1. So if in case result 2 is not equal to minus 1, then I will return it. I know it is found. Okay, minus 1. Result 2. Good. Now let us assume you did ascending binary search, you didn't find. You did descending binary search, you didn't find. Then control comes here. If control comes here, it means you have not found at all. So return minus 1. That's it, guys. That's it. This is your program. So let me step by step tell you what we have done. So first of all, reduce this also. If you notice, first thing I did is find the Bitonic point. So I'll enlarge that. Find Bitonic point. What did you do? What you did is you started basically you took your array. What you did is L was here, R was there, you found the mid element, kept checking if the middle element is the Bitonic element. For that few conditions you wrote. Guaranteed you will find the Bitonic element. Reduce it. Whatever Bitonic element you got, that now I will pass to my search Bitonic. So I will just tell system.out.println search Bitonic. To that I will pass my array, the B value which is what I need to search for, and the Bitonic index. Now if I go inside search Bitonic, what am I doing in search Bitonic? First thing I am checking if in case the element at the Bitonic index is the key. No. I am checking if it is greater than the Bitonic index element. If it is greater than, it will not be there at all. That also is done. Then I am checking to the left side by doing ascending binary search. I am checking whether it returned a positive value other than minus 1. If it returned a positive value, it found in some of these indexes. That index I will return. Otherwise, I am checking to the right side by calling descending binary search. Descending binary search will return a value to me. If it is not equal to minus 1, I know it has found it. Whatever it found, I will return. If both sides didn't find, it means I have not found, so I return minus 1. I hope you are able to think. I'll reduce this. Now, ultimately, the value that you are passing is nothing but 80. 80 is not there. But first, let's search for something that is there. I'll make it as 8. So, technically, this is the index. So, 0, 1, 2, 3. This is the index you should get. So, if in case I execute it, one can notice, oh, exception, go that side. Array index out of bound, which line? Click on that. So, guys, the reason why we got exception is we just did one small condition mistake. See, remove that highlight. Here basically we are checking if in case the element is a Bitonic element. No. If not, we are checking if it is to the left side. Left side means what? See, left side element means what? It is greater than left side element, lesser than right side element. If it is greater than left side and smaller than right side element, then the Bitonic element will only be in this side. Which means L was here, R was here. L should be brought wherever mid is, but we brought R. So make that as L. Similarly, here if it was in this side means what? Left side is greater, right side is smaller. So Bitonic element means the largest element will obviously be to this side. So R you have to adjust. So that is what I am saying. So that one typing mistake we did, but I hope you understood. Okay. Now let's execute. If in case I execute correctly, you have got 3 and 8 is at 3. Now let's give some other element. Maybe let's give it as 80. So 80 is not there. If in case I execute, clearly one can notice you have got -1. Any confusion till here? So I hope how to write this program you've been able to understand. However, their expectation was you must solve this in log n time complexity. Are we solving this in log n time complexity? Let's see. If I scroll on top, reduce this. Now guys, binary search means log n. Descending binary search, again log n. Find Bitonic point. Here also every time mid, left, right, you are adjusting, reducing the size of the input by half every time, which means finding Bitonic point also takes log n time complexity, right? So this search Bitonics is just a function inside which you are calling these three functions. It's not doing anything, which means these three are your core operations. Log n, log n, log n. If I add all of them together, I will get big O of 3 log n. You know, in time complexity, constants are not considered, so 3 goes. So what is the time complexity? Log n. So definitely PhonePe will be happy, HR would be happy. But I hope you understood how powerful binary search is and in how many different ways it can be asked, right? So I hope this question also was really interesting and you learned something new. Anyways, this is it from my side in today's class. Let's catch up in the next class. Thank you. Take care. Bye-bye.